All right, we're going to have one more lesson here on 4.3, and that's how to simplify radical expressions when you're adding and subtracting. Some you can simplify, some you can't, and I'll explain a little bit that. If you remember back to simplifying algebraic expressions, as long as they were like terms, we could combine them. And this gives you an example using the distributive property of how you do that. I'll show you that one more time. So what we do is we look for like terms. And so anything that has the variable r is a like term with 13r. So right there, those two are like terms. And also, I'm going to change this to adding a negative. But we also have this one and this one are like terms because they both have the variable t. As long as the variable is exactly the same with the exact same powers, then they're considered like terms. So we can combine the 13r plus the 4r. And we can combine the negative 12t plus the 8t. And then the minus 5 or adding negative 5 is just something extra. But the reason you can combine these now is because we have r multiplied by both of these. So we really have r times 13 plus 4, which is 17r. So you really don't need to do that little distributive process there. Just add the coefficients together. 13 and 4 makes 17r. Add the coefficients together here. Negative 12 plus 8 is negative 4t. And then plus negative 5. And then to be truly simplified, we don't want to have any adding a negative when we can just write those as subtraction. So write it as 17r minus 4t minus 5. So that's how you simplify. When you have radical expressions where you're adding, you can do the same thing. As long as you have like terms, you can combine them. And you might remember back to the little exercise we did back at the very beginning of this lesson. We were making these conjectures. We found that you cannot add. It doesn't work to add two radical expressions together just by combining the radicands. Likewise, you cannot do that with subtraction either. So, and that's this one here. But as long as we have like terms, then we can simplify by using the distributive property. And I'll show you what I mean by that here. So, if you look at this problem, you'll notice that this expression and this expression both have the square root of 2. So you can see that they just use the associative and commutative properties and rewrote the expression, switching around the problems, but then they use the distributive property to rewrite that one into a smaller expression. 3 times the square root of 2 minus 2 times the square root of 2 is the same as 3 minus 2, the quantity, times the square root of 2. So I'll do one with you here. Can we simplify these? We can, because we have the exact same thing being multiplied by both of them. So I can just write this using the distributive property as 14 minus 12 times the square root of 3. And that 14 minus 12 is just 2 times the square root of 3. So if you want, you can skip this step. And if you notice, you have like terms. And what I mean by that is you have the exact same radical. You can just combine or do the math on the coefficients of those terms. So the 14 minus the 12, just do that. That's equal to positive 2. And then times the square root of 3. All right, let's do a couple of those problems. Oh, sometimes, maybe I'll do one more example. And if you have room, you can put this somewhere. Let's say we have this. Square root of 2 plus 3 times the square root of 5 minus 8 times the square root of 2. Now, are there any like terms here? And I hope you notice that this has the square root of 2 in it, and so does this. So I can combine those two. So I have the square root of 2 and plus negative 8 times the square root of 2. I'll write those first. And then the square root of 5 is not a like term with the other two, so there's nothing I can do there. And also, if it's just the square root of 2 by itself, it's 1 times the square root of 2. 1 plus negative 8 is negative 7 times the square root of 2. And then this can't be combined in any way because it's not a like term, so the simplified expression would look like that. All right? Sometimes you may have to simplify first. And notice that this is not a simplified radical, neither is this. So when they simplified it, they ended up with 2 times the square root of 5 plus 3 times the square root of 5. Those are like radical terms. And so they just added the 2 plus 3, combined them. So let's try and simplify this first. Square root of 18, I hope you're getting better at this now. What is a perfect square factor of the square root of 18? And that's the square root of 9. So we're going to write, instead of writing the square root of 18, we're going to write the square root of 9 times the square root of 2. And square root of 8 also has a perfect square factor. It's square root of 4. So notice 9 times 2 is 18. 4 times 2 is 8. Now we can simplify that. Square root of 9 is just 3. That's the square root of 2. Square root of 2 can't be simplified. Square root of 4 is 2 times the square root of 2. And now we have like terms. We have the square root of 2 in both of those, so we can just combine. 3 plus 2 is 5 times the square root of 2. All right, I can do a couple more problems with you. Let's look at this and decide whether the two expressions are equivalent and explain your reasoning. Well, one way you could just check is just do that on your calculator, and then you can try and figure out the reasoning whether it's true or not. But if we do the square root of 2 plus square root of 2 plus square root of 2, and we do the square root of 6, let's see if we get the same thing. So square root of 2, and I'm going to close off the parentheses so I can add the square root of 2 to it again. If you don't do that, then you're still under the radical sign. So square root of 2 again, plus square root of 2 one more time. Now this last one you wouldn't have to close off the parentheses, but I'm going to just get in a good habit of doing that. And it's about 4.4. Well, is that the same as the square root of 6? 2.44, no, not really even close. So let's try and reason through why that is not true. Square root of 2, adding those three, they're all like terms. We can actually combine those. Now remember, it's really 1 times the square root of 2 plus 1 times the square root of 2 plus 1 times the square root of 2. And 1, since they're all like terms, we can just add the coefficient. 1 plus 1 plus 1 is 3 times the square root of 2. And then if you look at the square root of 6, would that simplify to that? Would they be the same? The square root of 6 has no perfect square factors. The only factors of that are 2 and 3, and neither of those can be simplified. So in simplified form, just like fractions, if the simplified form of both are different numbers, if they don't look the same, then they're not the same number. And just to remind you of that, like if you have 3/6 and 1/2, if you simplify those two, both of them, you get 1/2. And when you simplify them, they're the same. And then we know 3/6 is the same as 1/2. Likewise, you could do that with radicals. If you simplify them and you get the same exact value, then you know they're the same. All right. I think we'll do one more together here, and then we'll do the rest in class. I like this last one, number 18. It says, are these the same? Those two expressions. Pretty hard to tell the way they are. That's why we need to simplify them. You could go ahead and do it on your calculator and see. Make sure you're careful to use the parentheses correctly, but let's go ahead and do that. Negative 1/2 times the square root of 80 first. Negative 1/2 times the square root of 80. There's that one. That's about negative 4.47. And then the other one we wanted to do was square root of 45 plus the square root of 20 minus 7 times the square root of 5. Just move this over here and then see my expression. Square root of 45 careful to make sure you close off the parenthesis there. Plus square root of 20 minus 7 times the square root of 5. There we go. Hey, those are the exact same numbers. So we're going to work to show that now. Why they're the same. Negative 1/2 times the square root of 80 is equal to, 80 has some perfect square factors. The factors of 80 are numbers like 2 and 4 and 5, 8, 10. Let's see, 8 times 10, 5 times 16, 4 times 20, 2 times 40. Now of all these numbers, 4 and 16 are the perfect square factors, and we always want to use the biggest one that we find, and that's 16. So we can rewrite this as negative 1/2 times the square root of 16 times the square root of 5. And that's equal to negative 1/2 times 4 times the square root of 5, which is equal to negative 2 times the square root of 5. All right, so if we simplify this other expression, since we kind of already know they're equal, we should get the same thing. Well, the square root of 45, that's the square root of 9 times the square root of 5, we simplify it. And the square root of 9 is 3 times the square root of 5. So the square root of 45 is equal to 3 times the square root of 5. The square root of 20, if we simplify that, we get the square root of 4 times the square root of 5, which is 2 times the square root of 5. And 7 times the square root of 5. Well, you'll notice that these are all like terms. So we can rewrite this. I'm going to erase everything except my final simplified form of that first expression. See if I don't get the same thing. So this is 3 times the square root of 5 plus 2 times the square root of 5 minus 7 times the square root of 5. And remember, if they're like terms, which these all are, we can just combine the coefficients. And 3 plus 2 plus negative 7 is equal to negative 2 times the square root of 5, which is exactly the same as that. So we can see that, of course, they have to be the same because in simplified form, they are equivalent. All right, that ends the video, and we'll work on this in class tomorrow.